Hello everyone and welcome back to the channel. I said last time that we are going to consider more exercises with polynomials, but actually I thought that we need a little bit more knowledge in order to deal with the hardest problems about polynomials. So let's just move on with our topics, and in a few topics we'll return to the more advanced polynomial exercises. So in this lesson we are going to consider a very simple topic, that is equivalent expressions. So first, what are equivalent expressions? Two expressions are equivalent if for arbitrary values of their variables, the expressions assume the same numerical value. So what does that mean? Basically, the expressions are the same, okay? For example, if I have this expression, let's say x minus y times x plus y, okay? And I have another expression b, which is x squared minus y squared. I can substitute any arbitrary values for x and y, and a and b will have the same numerical value. Let me draw a table, very small table here. So this is x, this is y, this is a, and I'll make another row here. This is b, okay? So let's give three values. Let's say if x equals 1 and y equals 2, okay? Let's calculate a. So a in the first case will be 1 minus 2, 1 plus 2. So this is minus 1 times 3, which is minus 3. So a will be minus 3. What is b? In the first case it will be 1 squared minus 2 squared, which is 1 minus 4, which is minus 3 again. So you see, a and b are the same, okay? Let's give very quickly two more examples. X is 0, y is let's say 5, okay? So in this case a will be minus 5 times 5, which is minus 25, and b is going to be 0 to the power of 2 minus 5 to the power of 2, which is again minus 25. So minus 25 minus 25. And one last example, let's say x is minus 3 and y is minus 4. I'm just inventing numbers, okay? So in the third case, a3 is going to be minus 3 minus 4 minus 3 plus minus 4. This is going to be minus 3 plus 4 minus 3 minus 4, 1 times minus 7, which is minus 7. So this is minus 7. And what about b? b is going to be minus 3 to the power of 2 minus 4 to the power of 2, that is 9 minus 16, that is minus 7 again, okay? And so on and so forth. For every value of x and y, a and b are equal, okay? So a and b, we can start hypothesizing that they are equivalent expressions, but we haven't proven it yet, because remember, giving an example is not the same as giving a proof. So somebody can come and say, well, I'm not sure whether, for example, if x is 50 and y is 90, a and b will be the same. right? We cannot obviously check for all values because there are infinite amount of values we can give to x and y, and therefore what we want to do here is to devise methods for proving equivalent expressions. So methods for proving equivalent expressions. And the first method is just simplify both expressions and if the result is the same, then the expressions are equivalent. Okay, so for instance, let's see, I'll give the same example here. Later we'll have a more involving example. For instance, if a is x minus y, x plus y, okay, I multiply each with each, so I get x times x, x squared, plus xy minus xy minus y squared. These cancel and I get x squared minus y squared, which is the same as b. All right, and in this way I prove that a and b are identical, basically. Okay, b, if if a is the same as b, this means that if I move b on the left side with minus, I'll get a minus b equals 0. Okay, so this method simply says, therefore, if the difference of the expressions is 0, then they are equivalent. Okay, so in our example, I have a minus b. I'll check whether it's 0. So x minus y, x plus y minus x squared minus y squared equals 0, and I need to check whether this is correct or not. Again, I remove the brackets. X squared plus xy minus xy minus y squared minus x squared plus y squared. Everything actually cancel, and I get 0 equals 0, which is an identity. Okay, this is the second method. The third method, I rearrange the terms of one of the expressions in order to, in quotes, get to the other. Okay, basically I choose one of the expressions a or b, and I want to present that expression in the same way as the other, without doing anything with the other expression. Okay, I just leave the second one as it is. In this case, because b is already in standard form, there is nothing to do with b, and if I want to proceed by the third method, it's actually the same as the first method in this case, because what I did was I simplified a and I got to b. Okay, but let's give another example here. All right, let's have this example. Show that the expressions a and b are equivalent. So let me proceed by all the methods. Okay, I'll do the first, the second, and the third method on this example here, so you get a clear idea of the difference. Okay, so method 1. method 1 said I need to simplify both expressions and get to the same result. Okay, so I simplify a. This is u squared minus u times v plus u times v minus v squared minus u squared minus 2uv. Okay, so what is left is minus v squared minus 2uv. Okay, this is for a. And now for b, remove the brackets, minus 2uv minus v squared, and you see that this is the same as a. Okay, so therefore a equals b. What about the second method? I'll just cancel here very quickly because I don't have enough space. You can pause the video and copy if you want to. So if I proceed by method 2, method 2 says that I need to subtract them, so a minus b is going to be u plus v, u minus v minus u plus 2v minus v 2u plus v. For some of you this may seem boring, but it's not. I mean, it is boring. I'll be honest with you, it's boring, but it's useful also. So many boring things are actually quite useful, and you'll see why it's useful. Especially the third method is particularly useful. This is my preferred way of showing equivalent expression, the third method. So in this case, okay, again I simplify, plus uv minus uv minus v squared minus u squared minus 2uv, and now here minus times minus will give a plus, so this is plus here, plus 2uv plus v squared, and everything cancels. 0 equals 0. Yes, okay. And now we're interested to see the third method. Let's see the third method now. Okay. Method 3. So I choose one of the expressions, so I choose the expression a, and I will rewrite it to get to b without actually simplifying b at all. Okay, so a equals to, again remove the brackets, u squared minus uv plus uv minus v squared minus u squared minus 2uv. So I get to, as before, minus v squared minus 2vu. And now what I'll do is simply apply the distributive property of numbers, take the common factor outside of brackets. So what I have is minus v, and minus v here is repeating itself as a common factor in these monomials. Therefore I take the minus v, and what I'm left with in the brackets are the other factors. So because I took the minus outside, in the brackets I'll have plus and plus. Okay, so this is v plus 2u. all right. If I want to make a check, remove the brackets, minus v times v minus v squared minus v times 2u minus 2uv, and you get the same expression. But now you see that this is exactly the same as b. Okay, this is the third method. Without simplifying the second expression, present the first in an exact way as the second. Okay, all right, thank you very much. This was for today. Again, as always, like and subscribe. Next time we're actually going to talk about a very particular series of topics, which are formulas for quick multiplication. The formula a plus b in brackets to the power of 2, a plus b in brackets to the power of 3, etc, etc. Very useful stuff. So thank you once again, and I'll see you in the next one. Bye for now.